Okay, OCR, Foundation, Paper 2, January 2011. Gonna need a calculator. Okay, John works in a sandwich shop. He has £10 to spend on bread. A loaf of bread costs £1.15. How many can he buy? We got a calculator for this one. I really will just do trial and improvement idea with this. Obviously you can't get 10. What would 9 be? Turn it on. 9 times 1.15 equals, that's £10.35. That's too much. So I'm just going to write here, it must be 8. 9 equals 1035, £10.35. So maximum is 8. Cheese cost £9.70 for a kilogram. John buys 500 grams of cheese. How much does John pay for cheese? Well, 500 grams is half a kilogram, so you've got a half, £9.70. You ought to do that in your head, because you've got a calculator. 9.7 divided by 2, £4.85. Part C. Ham is sold in packs of 250 grams. Each pack costs £2.55. John buys 750 grams of ham. How much does he pay? Well, 250 and 250 is 500, and another 250 would be 750. So he needs 3 lots of 255, so it's 255 times 3, which I'm now doing on the calculator, and that's £7.65. Finally, cooked chicken costs £11.70 for a kilogram. John buys 0.6 kilograms of cooked chicken. How much does he pay? So you want £11.70 times by 0.6. Do it on the calculator. I'll try and get in the habit of putting the calculator here so you can see what I'm doing. So I wanted £11.70 times 0.6 equals, hit the SD button, £7.02. It's £11 for a whole kilogram, so we want just a bit more than half, so 7 seems about right to me. If it was £12, half of it would be 6. That's good. Okay, find the perimeter of the shape A. You've got to remember perimeters around the outside, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Find the area of shape A. How many squares? 1, 2, 3, 4, 5, 6. Units are given there. Find the area of shape B. Well, 1, 2, 3, 4, 5. That one and that one together make 6. That one and that one will make 7. Units are given for you there as well. Part C. What's a special mathematical name for the triangle? Well, you just need to be sure whether it's an isosceles or an equilateral. I'm just going to double check. Right. That there's about 3.8. That one there's over 4. So it's not equilateral. Those two are the same though. That one and that one. Yep. So it's an isosceles triangle. I sat on the exam. Find the area. There's 2 ways you can do this. The way I would see it, if I cut that in half there, that bit could flip round and run onto there, and I'd have all of this shape in here. 1, 2, 3, 4, 5, 6, 7, 8. 8 centimetres squared. We could have said base 1, 2, 3, 4 times the height 1, 2, 3, 4. So 4 times 4 divided by 2, because a triangle is base times height divided by 2. Either way you get 8. Okay, Rhea is playing a game to help her learn the names of shapes. She has 6 cards. She picks one of the cards without looking. Use these words to describe the probability of the events below. Okay, she picks a triangle. Well, there's 1 there. It's 1 out of 6, so that is unlikely, I would say, given the choices of the words there. Picks a hexagon. None of those are a hexagon, so there's no chance of that. So that's going to be impossible. Picks a square. 1, 2, 3 out of the 6, so evens. 3 easy marks there. Okay, question 4. The lines AB and XY are drawn, so AB and XY. Use one of the words to describe the lines AB and XY. Are they vertical? No. Are they equal? No. Are they congruent? No. Are they parallel? Actually, yeah, they are, because they're the same distance between them. So the word parallels are one we want. Write down the coordinates of point A. A is 1 along, 3 up. 1 along, 3 up. Write down the coordinate of point X. So that's -4 in the X, and then 2 down, so -2 there. Write down the coordinates of the midpoint of the line AB. So the midpoint is halfway along that line. One way I often do this, it's very obvious in this one, is to get a corner of a piece of paper, it can be a tracing paper in the exam, mark where the end is, fold the end of the paper over, so you're in fact halving it, make a neat fold, you know that's the halfway point, it's that point there. So that is going to be 3 along, 4 up. Mark on the grid the midpoint of the line X, Y, and write down its coordinates. Well, again, we can go for the tracing paper technique. That's not quite long enough, that piece of paper. So your other technique you might go for is just measure the line. I'm measuring that. That's 10.6. It's the calculator paper, actually. So all you want to do now is do 10.6 divided by 2. It's 5.3, so find out where 5.3 is. 5.3 is just there. That's where the midpoint is. Again, I could have done that by folding. It's 1 along and 0.5 up. And finally, on the grid, draw a line that's perpendicular to the line AB. That's my line AB. I've got to draw a line that's at right angles to that. That line's gone 2 along, 1 up. So the first thing I'm going to do is just estimate roughly what looks like a right angle. And you can really cheat with the ruler there, just by lining up the centimetre graduations like that one there. Just line it up on the line. Take it across anywhere on that line, but I'm going to go for that point there, and then realise that if it's 2 along, 1 up, it's going to be 1 along, 2 down is the other one for that, and just get that lined up neatly. There we go. Job done. Okay, so I've done that one as well. Okay, number 5. This chart shows the number of boys and girls in each year group who attend guitar lessons. Right, how many year 8 girls attend a guitar lesson? Right, first thing, girl side, boy side. It's not too clear, so I'm going to have a nice big B, a nice big G, just so I'm sure about which is which. Year 8 girls, there we go, read across, 8. How many year 10 boys attend guitar? Year 10s, boys going this way. What's between 8 and 10? Halfway, 9. Use the chart to compare the number of girls who attend guitar lessons with the number of boys who attend guitar lessons. Well, it's a bit hard to say. It looks to me as though there are more year 7s girls, and then they tend to stop by year 11, and there are less who start in year 7 from the number of boys, but they seem to keep at it a bit more. They actually want to compare the number of girls who attend guitar lessons with the number of boys. So I'm just going to quickly add up how many there are altogether. So 10, that one's 10, that one's 9, that's 8, that's 9, and that's 7. I've got my calculator, so just for speed I'm going to do that. 10 plus 9 plus 8 plus 9 plus 7. I'm just going to check I've typed that in correctly. I'll bring my calculator into view. 10 plus 9 plus 8 plus 9 plus 7, that's right. totally 43. Let's write 43 over there. Then for the girls, we've got 12, 8, 5, 7, 5, and 5. So let's add those up. 12 plus 8 plus 7 plus 5 plus 5 equals 37. Okay, so boys 43, girls 37. Make a little statement: more boys than girls take guitar lessons. Right, there you go, job done. Number 6, this diagram shows a cuboid of width 3, length 4 and height 2. Find the volume, give the units of your answer. Crucial bit that, we'll come down in a sec, give the units. So, here we go. I've got 1, 2, 3, 4, 5, 6 in a slice and 1, 2, 3, 4 slices. So 6 times 4 equals 24. That's one way to do it visually. The other way is, no, it's that times that times that. Or 3 times 4 times 2, which also equals 24. So the answer is 24. I think I'm done, but then it says give you units to your answer. Notice they've not written the units in down here. It's in centimetres, so volume, centimetres cubed. A swimming pool is in the shape of a cuboid. The swimming pool holds 480 metres cubed of water. The base of the swimming pool is a rectangle with a width 12 by 25. Okay, so I've got a rectangle that's 12 by 25. I've got to find how deep the water is, so I've got some water in it. I don't know how deep it's going to be exactly. 12 by 25, if I find the area of that, I'm using my calculator. 12 times 25 is 300. I've now got to get to 480 from that. So 300 times the height will equal 480. So 480 divided by 300 should give me the height. Just on the calculator, 480 divided by 300, 1.6. 1.6 metres. That seems about right for a swimming pool. It's quite a small swimming pool. A cookery book gives the following rule for length of time in minutes needed to roast a chicken. So it's the weight, should be the mass really, but it says the weight in kilograms times 50, add 20, gives you the time in minutes. How long will it take to roast chicken that weighs 2.3 kilograms? Really simple. If I were you, I'd use a bit at the top here. It's 2.3 times by 50 equals 115, and then add the 20 equals 135. So how it will take, and it's in minutes, how will then converting into hours? 135 minutes. Rose has 11 metres of material to make curtains and cushions. She makes 4 curtains. Each curtain is 1.7 metres of material. She uses the rest to make 3 identical cushions. So she needs 4 times 1.7 for the curtains. 4 times 1.7, 6 metres 80. And that's for the curtains. So the remaining is 11, take away the 6.8 metres, 11 minus 6.8, 4.2 metres. She's making 3 identical cushions, so now I need 4.2 divided by 3. You could do that in your head, because 42 times sorry, 7 times 6 is 42, so it's going to be 14, so 1.4 I think. I'm going to do it on the calculator for you anyway. 4.2 divided by 3 equals 1.4. Answer 1.4, and it's in meters. They've got that already, don't need to add it in. These are the first 5 numbers of a sequence. What's the next number in a sequence? Okay, any sequence ones, it's just about what's going on. So that's take 3, take 3, take 3, take 3. 3 less than minus 5 will be minus 8. What's the next number? Minus 8. Explain how you found the next number in a sequence. It is going down in 3s, so I subtracted 3 from minus 5. Here are the first 5 numbers of another sequence. What's the next number? Looking at this one, the difference there is 1, the difference there is 2, 3, 4, so the difference here is going to be 5. 11. What is the next number? Add on 5 to 11 is 16. Explain how the next number in the sequence, it's going up by 1 more than the last time each time. So I needed to add 5. Okay. Nearly at staples, nearly at the halfway point. Number 10. Ewan has n tracks on his MP4 player. Jake has 10 more tracks than you on his MP4 player. Write that expression in terms of n for the number of tracks Jake has. So Jake has n, 10 more than n is n, add 10. There we go, done. Luke has twice as many tracks as Ewan. Write down an expression where n times 2, you could write, you might not get the mark for that, we would normally simplify that to be 2n. Write down and simplify an expression in terms of n for the total number of tracks that the 3 boys have on their MP3s. So I'm just going to write Ewan, Jake and Luke, and write down underneath each of these what they've actually got. So Ewan was straightforwardly n, that was n plus 10, and Luke was 2n. So I've got 1, 2, 3, 4 n's, and then 10. 4n plus 10. These are the factors of 99. Which of the factors of 99 are prime numbers? So which of these numbers can only be divided by themselves? Or rather than that, the way I like to find it, and people are finding it easier, is which of these are in a times table other than the 1 times table? Well, 3 isn't, because 1 and 3 is 3, so that there must be a prime number. 9's 3 times 3, 33 is 3 times 11, 99 is 3 times 33 or other things, so 11 is another one, 3 and 11 are the 2 numbers. Let's put a comma between them. Now, I wasn't quite sure for that, but it's 2 marks, so I'm almost certainly going to have to give 2 numbers. It's got to be 3 and 11. Write down all the factors of 20. Well, 1 and 20, because 1 times 20 is 20. 2 and 10. Now 3 times 7 is 21, times 6 is 18, so it's not 3. 4 and 5. Now 5 and I'm going back where I've already been. It's going down again now, so let's cross that one out and cross that one and leave it there. And now do our list. 1, 2, 4, 5, 10, 20. Job done. A bank uses a code number on its computer. To crack the code, you need to find the 2 prime numbers which multiply together to give you the code number. For example, for the code number 91, the 2 prime numbers that crack the code are 7 and 13, and 7 times 13 is 91. What are the 2 prime numbers that crack the code for the following code numbers? Right, 69. I happen to know that that's 3 times 13, and both of those are prime numbers. If I didn't know, I could just start experimenting. So 3 and 13. 85, well, it ends in a 5, and any number that ends in a 5 is divisible by 5. So the only one it can have that's a prime number of that is going to be 5 itself. So one of the numbers has got to be 5. Then I'm going to do 85 divided by 5 on my calculator. I know what that is. It's actually 17. Is 17. So the other one is 17. Just double check that. 17 times 5 is indeed 85, and both those numbers there are prime numbers. Okay. This graph can be used to convert between pounds and kilograms. Use the graph to convert 12 pounds into kilograms. So I want 12 pounds. So let me read that. 12 pounds. Make sure I've got the pounds on there. Yep. Just be careful here, because this one here is going up in 2s. That's going up in 1s. But 12 is clearly there on that line there. So use 12. Up we go. Read across from there. Be very accurate. So 5.12345 didn't work. 5.2468, yes, that's 5.2. Convert 2 kilograms into pounds. Next question there. Let's read across again. So 4.1234, that's not good. 4.4, 4.6, 4.2, 4.4, 4.6, 4.85, no good, so there must be 0.4s. 4, 4.4, 4.8, 5.2, 5.66, so that there is 4.4 pounds. Quite our question that. Use the graph to convert 32 pounds into kilograms. Again, that's a bit tricky, because I haven't really on here to convert 32 pounds into kilograms. What I'm going to do for this one is look up 10 pounds. If I look up 10 pounds, actually even better than that, it's 32. If we look up 15, 15 is bang in the middle there. So let's look up 15, read off what that is. 15 is 7 point, now these are going up in 2s, so 7.8. Just going to write 7.8 down there for a minute. 7.8 is 15 pounds, so if I double that, is 15.6. That's my 30 pounds. I've now got to get 2 pounds as well, so let's go back and read off 2 pounds in here. There we go, it's just below that. Right on that line now, I reckon that's 0.9. 2 equals 0.9, so I need these ones together. 15, so 17.6 kilograms. Now it said here, explain how you worked out your answer. I'm going to say I found 15, then doubled, then I added the 2. So 7.8 times 2 equals 15.6. 15.6 plus 0.9 equals 17.6. I'm not sure exactly how much you need there, but that should definitely cover it all. Okay, Marcy goes to the gym every day of the week. Each day at the end of a session, Marcy records her pulse rates in beats per minute, BPM. Here are pulse rates for the first week. Okay, 89, 87, 88, 89, 84, 81, 84. Find the mean. Okay, well the mean is where you add them up and divide by how many there are. So let's do that. I'm going to put that close there so we get it right. 89 plus 87 plus 88 plus 89 plus 84 plus 81 plus 84. Got that wrong now, that last one. 84, that's better. 84, 81, 84, 89, 88. Just going to scroll back through. 87, got that right. That equals 602. So I'm going to do a bit of work. It's 3 marks here. So it's 602 divided by 1, 2, 3, 4, 5, 6, 7. Use a calculator. 86. There we go. Find the range of Marcy's pulse rates. So here I want the highest number, take the lowest. So 89 is the highest. Subtract the lowest, 81. Difference there of 8. There we go. For the second week, the mean of Marcy's pulse rate is 83 and the range is 5. Use the information answer to make 2 comparisons between Marcy's pulse rates for the first and second week. Okay, so I'm just going to write above here so I can get my head straight. The first week was 86 and the second week the range is 8. So, comparison 1. In the second week, her average at the mean is lower than the first. Just getting fitter. Okay, number 2, I'm going to make a comparison about the range. It was 8 here, it was 5 there. In the second week, the range is lower. She is becoming more consistent. More consistent. Right, next question. In a game, a fair coin and ordinary 6-sided dice are thrown. Complete the table showing all the possibilities, and 1 has been done for you. So we're going to have a head, and a 1, a head and a 2, head and a 3, head and a 4, head and a 5, head and a 6, tails and a 1, tails and a 2, tails and a 3, tails and a 4, tails and a 5, tails and a 6. That's it, can't have tails and 7, but you got carried away there. Use your tool to find the probability of throwing a head and a 6. So head and a 5. Head and a 5 is that one there. So that's 1 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1 out of 12. Okay, don't write 1 out of 12 or 1/12 because they won't get you the mark. Must be written as a fraction. Use your table to find the probability of throwing a tail and an odd number. So let's just mark those. I'll put across of these. That's tail and odd, tail and odd, tail and odd. 3 out of 12, which is the same as 1 out of 4. I've written this in there. 3 out of 12, which equals 1/4. Okay, draw an enlargement of this pentagon with a scale factor 2. There's no centre given here, so I can draw it anywhere I like on the sheet of paper. I'm going to start at the bottom here somewhere. That point to that point there. Well, that goes up 2 straight away, so I'm going to go straight up to 4. Again, you ought to be using a ruler for this, but I'll do it in pen, so you can see as I work it out. And the bottom one is 1, 2, 3, 4 across, so I need to go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Great, and then another 2 up from there. And I can find the halfway point is on this line here somewhere. But there, it's 2 along, 1 up, so let's go 4 along, 2 up. I've drawn that. If you're doing it in pencil in the exam, it's sometimes a good idea just to squiggle it in so the examiner can see your shape clearly. Part B, complete the pattern so it has rotational symmetry order 4. I'd normally do this with a piece of tracing paper, so let's try it and see. It's also going to be a little bit difficult because the aspect of the screen is widescreen and it's not as it was before. So I just need to spin that around, and that will go down to there once, round to there twice, and 3 times. So I'm going to trace that out as I see it. Do it quickly for you now. Let's see it down there. and again. Shade that in, twist it around again, there we go, and the last time. And that shape can be spun around 4 times to fit. Hence rotational symmetry order 4. Okay, calculate 3.6 times 4.7 divided by 5.1 minus 3.6. Oh, I just love these questions because if you've done them once you can always do them. So first of all, it's a fraction. So I want to use my fraction button. This is absolutely about you being able to use your calculator properly. Fraction button's there. Okay, so now I've got my top bit and my bottom bit. The top bit is 3.6 times 4.7. 3.6 times 4.7. Done. Use the cursor key here to scroll down one. Now I'm on the bottom half. 5.1 minus 3.6. Press equals. Okay. It's 282 over 25. So you could write in the workings 282 over 25 and SD it to get the answer. 11.28. Dead easy. Okay, the next one, again it's a fraction, but on the top it's just a number 2, so just type the number 2 as I've done. I'll do that again for you. Fraction button, 2, scroll down to the bottom as I just did there, 3.6 plus 1.7 equals, SD it. Right, let's write it all out, 0.3773584,906. They want that to 2 decimal places. First, second, I would chop it off there. So it's somewhere between 0.37 and 0.38. So between 37 if you like and 38. 37.7 will be nearer to 38, so I'm going to go for 0.38. There we go. Other people say, look next door, it's more than 5, round it up. So that becomes an 8. Okay. Sarfraz scored 13 out of 20 in his English exam, 62% in his math exam, and 23 out of 35 in his science exam. By converting those results to English science to percentages, put the exam results in order lowest. Percentage first, you must show your working. So, set it up quite nicely down here. We had English, maths, and science. English was 13 out of 20. Maths we knew was 63%, and science was 23 out of 35. Get your calculator out again, really simple. First one, 13 divided by 20, SD at 0.65, so 0.65 is 65%. We know the mass is 63. Science was 23 out of 35, which is 0.657, which is 65.7%. Okay, so it says lowest first, so the lowest percentage was the math, so that's the first one. The next one above that is the English, that's 2, and the third one there was science. Now it says, by converting results to English, science, put the exam results in order, lowest percentage first. Now I'm not quite sure whether they want you to give the English, maths and science or the actual numbers, so I'm going to give both and go for clear M, 63%, then a clear English, E, 65%, and a clear S for science, 65.7%. And that way I've got all my answers written down. Okay, here we go. Josh collected these data following showing the midday temperature in degrees Fahrenheit, degrees F for 15 places around the world on one day in December. Draw an ordered stem and leaf diagram. Okay, let's go over here. OK. All, order, and key. So I'm ready to go. reserve, I need that. Right. Okay, I'm looking around here, I'm just going to go for it. The lowest tens digit I've got, I think, is a 3. So I'm going to go 3, 4, 5, 6, 7, 79. Oh, and Bangkok was 84. Okay. There we go. Now let's start recording the data. First one, 46, 84, 73, 57, 34. Next lot, 59, 70, 61, 34, 77, 79, 54, 81, 68 and 63. Okay, just going to check I've got all my data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5. 3 5s is 15. Got everything there. Stem and leaf's there. It said an ordered stem and leaf. Order. So I've got to do that now, so recopy it. I'm going to go 3, 4, 4, 4, 6, 5, 4, 7, 9, 6, 1, 3, 8, 7, 0, 3, 7, 9, 8, 1, 4. Just check again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Still got all my data. Should be finished. Whoops. Key. Pick any number in there. I'm going to go for 6 stroke 1 is 61 degrees Fahrenheit. Okay. Josh chose 15 places, each beginning with a different letter from the alphabet. Suppose Josh had chosen Lisbon instead of Luxembourg to show in his table. The temperature in Lisbon was 57. So I'm just going to go back up here a minute and just write a 57 in there. Explain what the effect this change would have on the mode and median temperatures. Right, so the median temperature is the one in the middle. Oh, sorry, that bit and there's a couple of seconds. Let's do the mode one first. Explain what effect on the mode. That's the most commonly occurring one. So at the minute, the only recurring one we've got is 34. So Luxembourg was one of those, which was 34, and that would be swapped for 57. So the effect on the mode would be, it would change from 34 to 57. The effect on the median is the one in the middle. Now, let's move on a bit for you. 1, 2, 3, 4, 5, 6, 7. It wouldn't actually have any effect at all, because that 4 would just come into there instead, and the middle would still be the same. Effect on the median, none. There we go. We're getting there slowly. Okay. Solve y divided by 5 equals 20. Y divide 5 gives me 20. So working backwards, 20 times 5 will give me y. 5 times 2 is 10, 100. You may have just spotted that 100 divided by 5 is 20. Okay, this one's slightly different style of equation. I've got p's on both sides here, so I'll do a bit of balancing. I'm going to subtract a p from both sides. That will leave me with 2p plus 6 equals 18. Then I'm going to use my flow diagram. P times 2, add 6, gives me 18. Working backwards, 18. Take the 6, that's 12. Then divide by the 2 is 6. Should be 6. Okay, can just check and see if I'm right actually for that one. That's what I like about equations. 3 6s at 18, 18 at 6 is 24. 6 at 18 is also 24, so 24 equals 24. I know I got that right. 6 is definitely the right answer. Okay. In the year 2000, the average price of a house in the UK was 81,600. By 2005, the average price has increased by 93%. Find the average price of a house in 2005. So we've got to increase 81,600 by 93%. So we could find 93% and add it on. Quite easy. One method for that would be to do, it might be a method you'd use, so I'll show you this way first of all. Okay, 10% is going to be 8160, so 90% is going to be 9 times that. 9 times 8160 equals, I'll write that down, 73440. 1% is going to be equal to £816. So 3% is going to be equal to that times by 3. 816 times 3 equals 2448. Okay, so I want this number, the 90%, and I want the 3%. I'm going to add them together. 73440 plus 2448 equals 75888. That's about right, because the whole amount was that. 92% is going to be shade less than that. So it's increased by that much, so I've got to add that on to the original amount of 81. So I'm now going to plus my 81,600, and that gives me 157,488. Okay, that's what I think it is. That's not the way I would have tackled that question. I would have said, but it's a way you may very well do it, so I've shown you that way. I would have said increase by 93% is times by 1.93. And I would have done 81600 times by 1.93. I'll do it for you now. I'm not trying to be clever with this, but this is just the way that you ought to be doing percentage increase. But if you're not used to it, the other way was fine, just takes a bit longer. And that equals 157,488. Wow, it's the same. That's lucky, isn't it? There you go. In 1995, the average price of a house was 50,900. Find a percentage increase in the average price of a house from 1995 to 2000. So in 2000 it was 8160, in 1990, so we've gone from 50900 up to 81600. Okay, this is sort of doing the reverse method we've done here where we times it. I'm going to do 81600 divided by 50900 on the calculator. 81600 divided by 50900 equals, let's do that, 1.6035. Sorry, 31. So that tells me that it's an increase of about 1.6, so 60%, or 60.31%. So I'm going to write down here 60.31%. That's the increase it would be. Is that about right? If it went up by 50%, it would be another 25,000, which gives you about 75,000. It actually went up to 86, so it's a bit more than 50%. That seems about right to me. Okay, I'm trying to get there quite quickly. Jenny is making a bird box for a technology project. Seems that everybody makes those for their technology project. This is the side elevation of her design. Calculate the length DE. So we've got to find this length DE. Well, we know that's 15.5, that's 26. centimetres. So quite clearly it's 26, the difference between them, minus 15.5, which equals 10.5. That doesn't seem right to me. Let's check that again. 26. Yes, it does. 10.5. Calculate the length A to E. Well, it's a right angle triangle. They just told me this bit here. I've worked that out there to be 10.5. We know this here is 14 from below, so we should be saying this is the Pythagoras question. So nearly it was on there, and yep, it's turned up. So square on this side, square on that side, add, take. It's a fairly straightforward one. 14 squared is 196. You can use a calculator for that. I just know that it is 14 squared equals 196. I don't know 10.5 squared, so I'll have to use a calculator. Squared equals 110.25. So this bit in here is going to be 110.25 plus 196, and then square root it. Okay, so that's my answer there. So I'm going to write in this box here 306.25 to get the method mark for adding the two together, and then I'm going to square root that. So to do that, I'm going to do square root. So I've got the calculator for you again. Hit the square root button, and then I'm going to use the answer function here. Square root answer equals 35 over 2. Let's do that, 17.5. So I'm saying that's 17.5. On the diagram, it's got to be the longest side. Well, that was 10, that's 14. That is the longest side, and it's not majorly too long. That looks good to me. 17.5. And notice, sorry I've written 17.5 in there, you've got all this space for working. It's equally okay to show your workings on a diagram up here, and that's the way I like to do it. So you can use that diagram with your workings if you need to. Don't worry about having to put writings on the line. You'll get your method marks, they're up there. That's absolutely fine. And now, trial and improvement. If I was doing this paper, I'd be really happy because I knew that Pythagoras was going to have to come up, and I knew that trial and improvement would come up. So these are two questions I was expecting to be there. Okay, use trial and improvement to solve this equation. X, I'm going to write a big few here. X cubed minus 2x equals 7. Give your answer to one decimal place. Show your results and their outcomes. Okay, so first of all, I've no idea. I'm going to guess with the number 3. So I start with 3. I'm going to write down what that is. Use my calculator. So it's 3 cubed, use the cube button, minus 2 times 3. And that equals 21. Quite clearly, that is too big. Let's take it back down to 2. Now, you can type it all in again, or you can use the replay and just go there. So I'm going to try 2 instead. Saves a lot of time. 4. Ooh, what's wrong with that? Too small. Now you must write these bigs and smalls and the answer you're getting, otherwise you won't get the marks. Right, I'm going to go for 2.3 this time, because 2 was a bit nearer. So back to my calculator, again use the replay button. 2.3 there, and 2 times 2.3. 7.5, we're getting closer. That's too big still though. Let's try 2.2. Again, use the replay. You can see how important it is to use the replay, because it's really speeding things up. Right, just do that little delete to that one. I was going for 2.2. And that one there, don't forget to change the second bit in your substitution as well. 6.2. Whoa, that's too small. Okay, right, so it's somewhere between these two. It's between 2.3 and 2.2. I've only got to go to one decimal place in my answer, so I can only use point somethings as I'm typing in the calculator, and it's between these two. I'm aiming for 7. It looks to me as though well, that's 0.8 away, that is 0.5 away, so I'm going to go for 2.3 being my answer. Now, you only get 3 marks if we did that. You are supposed to do the middle bit of these two and evaluate what that is in order to get the last mark, or to evaluate which one of these two you need. I find students get so confused with that, so I'll just tell them to decide which one it is and write it down, and now we do the bit that's just keeping the examiner happy. Halfway between 2.2 and 2.3 is 2.25. Go back to my calculator, just change that to 2.25, and that one there also to 2.25, press equals, and that came up as 6.8, and that is too small. That's all you've got to do. That last line there, playing about there, has got you that extra mark. Don't need to know why. You just go to one decimal place, and when you decide what your answer is, find the midpoint of those two and work that out, and just write down whether it's big or small. That'll get you the mark. Okay, now I think that's the end of the paper, but as always I'm going to check that it is, and it is blank. My final checking thing now is just to flick through every page and look at the page number. 23, 22 you can't see, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and then 1 first page. Why have I done that so many times? I've seen people in the last 2 or 3 minutes of the exam suddenly discover that they accidentally turned over like that, and they went from page 3 straight to page 7 when they did the paper, and just as they're about to hand it in, they flick it over and find out, not the case here, that they've got a whole 2 pages they haven't done. So just check whether using the page numbers that you've done every single page. That's my first check when I've finished. The second thing now is to go back through and do every single question again properly. Pretend the answer's not there and just work it out again. Hope that's helpful to you. Do check your workings carefully. Make sure you leave no blanks. If there's questions you haven't done, have a guess. There's nothing wrong with having a guess. You may be really lucky and get the mark. Okay, just so you can be sure which one that was. That's OCR, GCSE, Foundation, January 2011, Paper 2, and you're allowed to calculate for that one. Hope that's been useful to you. Please look at the other ones.